Under the ground, I'm going to look at this as new water. Okay? If this is old water out here in the sea, this is new water over here. It's the same thing that was out here, it's just that we've separated all the stuff out of it, and it's fallen back down to the ground. So, focusing back on TDS, focusing back on what's in the water. As we start off in the new water side, where's the first place that we're starting? Well, we're starting off on rivers, brooks, streams. What do you think the TDS level is of those? Creeks, rivers, streams. It's probably going to be pretty low, right? Because it's brand new water. The average TDS level, so dissolved solids level in rivers, is right around 30 to 50 ppm, 30 to 50 parts per million. So we've really separated a lot of stuff out. It's pretty clean water. So that river water that's going down through the mountains here and coming down and making its way into the storage areas is pretty clear water, right between 30 to 50 ppm. So Starbucks, who is a very important, they use water treatment because here's the thing about coffee. What's in that box right there is 97% water. Okay? 97% of it is water. So the primary ingredient in coffee is water. Starbucks is they're focused on what the quality of their water is, so that every time that they put coffee out in a box like that, it's the same. We pour it out, it's Starbucks coffee, we get exactly what we think we're getting. Probably not a lot different than when I go into McDonald's, I order that Big Mac, I want my special sauce to be special sauce. Right? But Starbucks is focused on what their water quality is, and they've determined that ideal coffee water is anywhere between 60 to 100 ppm of total dissolved solids is ideal for coffee water. So does anybody know where Starbucks is headquartered at? Seattle, Washington. It just so happens Seattle's primary water supply is the Columbia River. And what do you think the TDS level is of the Columbia River? 60 to 100 ppm. So it's really weird. Wow, Starbucks just happened to happen in Seattle, just out of the blue. They just made great coffee right there in Seattle. Weird. How did that happen? They had an ideal supply right there at their feet that they could do that with. Another thing, you always hear about bagels from New York City. Well, New York City is on the Hudson River. What is the TDS level of the Hudson River, roughly speaking, in New York City? 40 to 60 ppm. So they have really good water supplies that happen to provide this great recipe materials for what they're doing with the water. So that's river water, fairly new water. Cities on rivers, cities in places that are sourcing water from rivers are going to have TDS qualities like that. So it fits a lot of the ideal consumable water, ideal for a lot of different stuff. Let's make our way down. Rivers are really new water. As we come down to lakes and reservoirs, that water's sitting there for a while. Water's sitting there for a while. We're getting some evaporation, so we're getting some concentration that's happening here. I live in a city called Kenosha. It's on Lake Michigan, and it's right between Milwaukee and Chicago. And all the cities so Lake Michigan water is, Great Lake waters usually run between 180 to 250 ppm. So you get an idea, if I'm going from river water, 40, 60, 80 ppm, now it sits for a while, I lose a little bit of that water, just like in the swimming pool in the back, you get a little bit of concentration. I lose a little bit of the water off the top, it starts concentrating. Big lake water, right around 200 ppm. That's still pretty good. Our hardness in rivers is usually somewhere between 1 to 2 grains of hardness. You get into Lake Michigan, it's going to be about 7 grains of hardness. So again, you're getting some concentration, but it's still fairly new water when you think about it. Lake water's now making its way out to the sea, and what's the TDS level of seawater?
30 to 60.
It's 30 to 60,000. New surface water, old surface water. Does that make sense so far? All right. All of this fresh water that's over here, we've talked about surface water so far. We also have something called groundwater. So a lot of this water that's falling to the ground is seeping into the aquifers that are below ground. The primary contaminant of water that's on the surface here, lakes, rivers, and streams, is going to be particulate contaminant. Primary concern is actual physical things that are in the water. So if you have stuff that's actually floating around in the water, that's what's usually, because the water that's new and on the surface hasn't had time to dissolve a lot of stuff into it. So your primary concern is going to be particulate contaminants, physical things in the water. Now what are some of those things? Sand, grit, gravel, logs, also organic material. All of the little things that it breaks down to. Bugs of all different sizes, bacterias, cysts, algae, all of those things those are the things that we're most worried about with surface water. As the water makes its way down through the ground, it's actually coming in contact with a lot of different things, so it has the opportunity to dissolve the things that it comes in contact with. All along the middle part of this country used to be a settling area for a big sea that used to be across the middle of the country. And that's all of those things that used to live in that sea settled down. You have big limestone deposits. So the water that makes its way down through that limestone dissolves that limestone and marble and makes hardness and things like that. Iron ore deposits, dissolves all those things into it. Well, what happens when the water goes down through the ground, it comes in contact with all of those mineral deposits in the ground and it dissolves it. So the primary contaminant in groundwater is dissolved solids. Just so happens that another benefit of this function is that we're filtering out a lot of our primary contaminant out here because it's going through a big sand filter. So we tend to get clearer, cleaner water too when it comes to particulate contamination. Now all of that being said, so that's 3% of our water supply is fresh water. And we depend on 3% of the total of the water supply that we have here on Earth. Here in the United States, 80 to 90% of the fresh water in this continent is in groundwater storage. So even though we have a very large area of reservoirs and lakes and streams and so forth, 80 to 90% of our fresh water is underground. Groundwater is the primary water used for 53% of America. So it's about a 50-50 split. Roughly speaking, people are sourcing about half their water from surface water supplies, half their water from groundwater supplies. Here's another thing to take in note though too. Even with that to give you an idea of how small of amount of water that we have that we can readily consume, even out of that 3% of our total water, about 90% of it is frozen in the caps on the North and South poles. So even being with the fresh water that we have, majority of it is still frozen in the caps. Okay, so it's a very small amount. And that, again, what are we up to now? How many people are on Earth? What is it, about 7 billion people now? With the amount, and we all need fresh water, so that, again, we're all in a business, we're all in an industry that these concerns and these things that we need to be aware of are becoming more and more prevalent. In general, the more dangerous water supply is considered to be surface water. Why do you think that is? Yeah, more things can get in, more contaminants, I think I heard down there. And it's not so much necessarily more contaminants, it's also the kinds of contaminants. The bacterias, the cysts. Now the hot new thing, the dangerous thing that's happening on Lake Erie now is the blue-green algae blooms that are happening on Lake Erie, and getting rid of it is causing toxic gases to be produced. So surface water supplies are, the consideration is that they are the more dangerous water supply because of that. Is because for human consumption, those are the things that are going to be the most dangerous for you if you just take a glass full of hot water and drink it. Groundwater is considered, even with the things that you think about that are in it, lead, hot, heavy metals and things like that, groundwater is considered to be a more safe water supply because of all the filtration that it goes through. In general, which water supply has higher levels of dissolved solids?
Groundwater.
Groundwater. Okay, so there, that's the 101. That's the 101 lesson. Here we've got particulate contamination, actual physical bits and pieces that are in the water. This, we have more of a mix where the contamination is part of the water. Okay? So let's talk about how do we fix this? Do we need to fix it? What do we do to address these issues? I just thought I'd throw a little pause in there. Give everybody time to ponder that question. What are we going to do to fix these issues? Let's jump ahead. Let's talk about particulate filtration. Let's talk about addressing particulate filtration first, and then we'll get into the rest of it, okay? So what are we going to do to take out bits and pieces that are in the water? The easy way to do it is to make a screen or a sieve, and whatever size we want to make it, catch the things out of the water. See, it was yesterday I had a nice little donut hole, so it was a nice little demonstrator. I'm not going to grab a piece of watermelon.
City minis. That's good,
All
right?
Yeah, that's a little bit more calories.
Ah.
So what we're going to do to catch physical things out of the water is we're going to create a sieve. We're going to